awesome. There you go. Good morning. Hello. Welcome to Office Hours. Today is September 10th. We'll be going over kinetic energy, potential energy, and total energy, and the addition of gravitational potential energy. And hopefully it won't take that long. At this time, please take out your notebooks. And if we have time, we'll use Gizmos as well. But the main thing you should have right now is your notebooks. So please give me a thumbs up or a green check mark if you have your notebooks ready. Thank you, Sarai. I see you right there. Thank you, Daniela. Thank you, Hugo. Awesome. Give me a green check mark or a thumbs up if you have your notebooks or somewhere to take notes ready. Awesome. Thank you, Layla. Awesome. Let's get started, everyone. If you have any questions throughout this time frame, please feel free to type in the chat box, or also, let me do this real quick. Also, you can go to Piazza and now open the office hours for today. So I'll do a live Q&A. I'm going to start the Q&A now, and I'll have it open for about 1 day, for 24 hours. So you have anything going on right now, you have any questions, you can post on Piazza, and I'll get a notification, and I'll be able to answer accordingly, okay? Let's get started. Okay, so the things we have gone over. Oh, hold up, sorry. Okay, here you go. So let's start off with the first thing we have. So we know what total energy, kinetic energy, potential energy is, but let's go over that real quick. Kinetic energy. Oh my gosh, what was that? There you go. Kinetic energy. Kinetic energy basically equals the releasing of energy. It has to do with moving objects. And I'm going to put one more thing. It is the fastest, or its maximum is at its max when at lowest point. Okay. So kinetic energy is the releasing of energy. So you release energy by moving objects. So if an object is moving, it is releasing energy. And it's at its max when it's at the lowest point. And kind of like a little swing, and I'll make more sense as I do an example, but its maximum kinetic energy is when it's at the lowest point, Let me emphasize that real quick. Lowest point, okay? Max when it's at the lowest point, okay? And then potential energy, you have good old potential energy. Potential energy is basically the opposite of every single of kinetic energy. It is the storing of energy. It's when objects are not moving, so objects not moving. And it's at its max at highest point. So once again, I can make this a little bit bigger so you guys can see it. Potential energy is storing of energy. So you're building up energy to release it. So you're building up in order to have energy to move. So when it's not moving, when it's at rest, I'm going to put a little emphasis right here. I'm going to put rest right here. Rest. When it's at rest, that's when it's storing energy. And it's at its max at the highest point. So at the highest point, it's no longer moving. That's when it has the maximum energy, maximum potential energy. Okay. Give you guys about a couple more seconds to write that down. Give about 15 more seconds, and then we'll move on to the next one. If you want, you can start writing total energy, because that's the next one we're going to do. Awesome. Let's move on. Like I said, I'll post these notes on Google Classroom later in a bit after this, so don't worry about it if you can't get to it. So the last one is total energy. And like I said, total energy equals the sum of kinetic energy plus potential energy. And some key points to know about this, it's that it never changes. Never changes, always consistent. Okay, so if I have an example right here, if I want to find the total amount of total energy between, let's say, 33 joules of kinetic energy and let's say 47 joules of potential energy, if you add them up, that is going to be 80, right? 80 joules of potential energy. And don't forget, joules is our unit of measurements, okay? So joules is our unit of measurement. Unit of measurement for energy. There you go. So the total energy, it never changes. It's always consistent. It's always transferring, always transferring. Oh, I'll put that keyword right there. I like that. Always transferring. Always transferring. Okay. Oh, I don't think you can read that handwriting. Always transferring, okay? So it's always transferring, always transferring between kinetic energy and potential energy, okay? And don't forget the joules. Joules are our units. We need to know 80 watt, 80 watt, 33 watt, 47 watt, joules. Joules is energy. I always think of joules equals energy. Energy equals joules, okay? Give you guys about 15 more seconds for that. Once again, if you have any questions, please post them, and I'll be able to let you guys know. So a couple more seconds to write that down. Okay. Awesome. Move on to the next one. Now, let's focus on one specific type of potential energy, and that is gravitational potential energy. Gravitational potential energy. Okay. Awesome. Okay. So gravitational potential energy is basically potential energy right, being affected by gravity. Being affected by gravity. So that means it's always pulling down, always pulling down. Pushing or pulling down. And to be more specific, with gravity, everything on Earth is affected by GPE, by gravitational potential energy. That's why a lot of the reasons why we also like get really tired when we're running up a hill is because when we're running up a hill, that gravitational potential energy is pushing us down. Gravity is pushing us down. That's why we get more tired when we go up a hill than when we go down a hill. Okay, that's why we use more muscles to go up a hill than when we do to go down a hill. Okay, you guys got about 20 more seconds for that. Okay, about 10 more seconds. Okay, go on to the next one. Let's do an example though. Let's try making an example. Let me see if I can take a screenshot of this and copy this. I'm gonna do a quick example. I'm gonna see if I can take a screenshot of this. You don't have to be on Gizmos yet. I'm just gonna see if I can take a screenshot. Oh, it seems I can't. Okay. Let's do some magic. Hold up. I should be ready for that since the beginning. Okay, copy. There you go. Awesome. Are you guys about, I'll give you 20 seconds to just draw this real quick. It doesn't have to be perfect. You can literally just draw like a string with a ball. So it doesn't have to be super perfect, but just do that for me. Okay. Now, let's make this, let's make this GPE equals green. Or not like that, sorry. GPE equals a circle. And then let's do kinetic energy equals an X. Okay? Let's do that. Now, for an example right here, we know that there are 2 points that has the highest gravitational potential energy. And those are the highest points. So when they're swinging back and forth, okay? So let's say if I continue to do this, right? If I continue to do this with the ball, that's a ball. So it's swinging back and forth, right? Like that. It's not perfect, but hopefully you guys get the idea. We know that the highest point when it's the maximum gravitational potential energy are going to be at these 2 points. Okay? Those are going to be the highest gravitational potential because it's at the maximum height. Max GPE because max height. Okay. Okay. These are our maximum height and it's our maximum gravitational potential energy because we are not moving. It's literally still. It is literally still. Okay. So that means that at this point as well, let's do the color. Ke is 0. Oh, my bad. Ke is 0 joules. So kinetic energy is 0 joules at the highest point. So right here, kinetic energy is 0 joules. Okay? Because it's not moving. If it's not moving, do you have kinetic energy? No, you don't have kinetic energy. But where is kinetic energy at the highest, though? That will be at the way bottom. Oh, blue, right? Blue is X. Right here. At the lowest point. So right here, at the lowest point, our Ke is the highest. Ooh, I don't think you guys can see that. Ke is max. Actually, let me make this better. Let me make it thicker. Ke is max. So kinetic energy is at its maximum at the lowest point. So let me put this, lowest point. At the lowest point. Okay. At the lowest point. That means it's moving the fastest. So that means if it's moving the fastest, kinetic energy is at max. And that also means that the gravitational potential energy will be a 0. Okay. I'll have enough space to do that, but hopefully you guys can get that idea. Maybe I can't. Hold on. What if I do this? GPE is 0 joules. Okay. GPE is 0 joules. Okay. Doesn't seem to be some questions here, so I'll give you guys a couple more seconds. I'll give you guys about 30 seconds to write it down. No, it's a lot. Let me know if something looks kind of janky, and I can maybe make it better. So like I said, we got a little swing, a transferring of energy. Oh, what did I do? What did I do? What did I do? Okay. So we have a little swing back and forth. We know at the highest point, we have the max gravitational potential energy. At the lowest point, we have the max is kinetic energy. Oh, what did I just do? What did I just do? I'm sorry. Seems like I got too excited. There you go. Okay. So like I said, kinetic energy is the highest at the lowest point, and they flip around, okay? So if gravitational potential is the max at the highest point, that means kinetic energy is at the lowest point. And if kinetic energy is at the highest point at the lowest point, so it's max at the lowest point, then that means gravitational potential is 0 joules. Awesome. Okay. Let's move on. Now at this point, we could use our gizmos. So at this time, let's see, we're going to transition into gizmos. Let's transition into gizmos. Okay. Let's transition into gizmos. So I'm about to flip this over. Now I'm about to go here. And please make sure you're on the energy of a pendulum. Energy of a pendulum. I'm going to pause my time real quick. About 3 more minutes. But it should be enough for me to just teach you guys one more thing. So give me a green check mark or a thumbs up if you are on the Gizmos simulation. Awesome. Thank you, Ugo. recording. Awesome. So we have all you guys there. So the first thing I want you to do is go to your degrees and change it to 40 degrees. So not negative 40, but 40 degrees. So all the way to the right. So please do so at this time. Your mass, length, and gravity should be like this, the same, 0.5 kilograms, 2.0 meters, and 9.8 meters per second squared. Okay? So these don't change, but make sure you change the degrees to 40, okay? Once you do that, let's go to the graph. So go all the way to the graph. So there's description, table, bar chart, and graph. So let's go to the graph, and let's actually click on, make sure the potential energy is clicked, and let's just do that by itself, okay? So let's click play. So as you can see, if I stop it at the highest point, so let me see if I can stop it at the highest point. Right there. Right? So if I move it, so you can drag it. So if you click on it, you can drag it where you can see where it stopped. So as you can see, at the highest point, gravitational potential energy is at the highest, right? Now what happens if I click play and then I stop it at the lowest point? Oh, that didn't work. There you go. So if I pause it, if I drag my mouse again, look at that. My gravitational potential energy is now what? At the lowest point. So that just further clarifies what we've been learning, right? What happens if, now let's reset it. So click reset. And now add kinetic energy to it. So now add kinetic energy. Okay. Now let's click play. So kinetic energy should be opposite, right? And let's do this. Look at that. So when kinetic energy is at the highest point, potential energy is at the lowest point. So let's try pausing it at the highest point again. Let's see. I'm going to pause it right here. Drag your graph. Look at that. It's a little bit off, but you can tell that the light green, which is kinetic energy, is at the lowest point because it's all the way at the maximum height. And you can see potential energy is at the highest point because it's still, it's not moving at all. But what happens when we move it to the bottom, all the way to the lowest point? Drag your mouse. Look at that. Now it's the opposite. Kinetic energy is at the highest point, and potential energy is at the lowest point, right? So it's a transfer of energy. Now, if I add total energy, if I click reset, and I add total energy, oh, time's up. If I add total energy to it, what should happen? Should total energy be changing or should it stay consistent? Well, we say it should stay consistent, right? But let's see. Look at that. It's staying consistent. It's not moving at all because it adds up kinetic energy and potential energy, and it totals. It will always total the same because no energy is being lost and no energy is being created. Don't forget the law of conservation of energy. You can't create nor destroy energy. It can only be transferred. I like how the graph looks. The graph looks really pretty. Now, you can change it to the bar graph, the bar chart, and that does the same thing, just in different data. To see how it's changing back and forth, but the total energy stays the same. And in the table, it's just its values. You can pretty much tell the same thing. Look at the lowest. I stopped it at the lowest point. So at the lowest point, potential energy should be the highest. Look at 2.228. And then kinetic energy should be the highest, and the potential energy should be the lowest. But if I stop at the highest point, look at that. Potential energy is now higher than kinetic energy, which is 0.23 joules in this case. So see, even though it looks a little bit weird, the data still reflects that. Okay. See, and that's pretty much it. That is all I have for you guys today. That's pretty much the best thing I have for you guys. You guys should be able to answer, hopefully, the Edpuzzle video and the question that's attached at the end of the Edpuzzle Remember, watch the puzzle all the way until the end. If not, it's not going to save your progress, and it won't transfer to Google Classroom, which means it won't transfer to Synergy. Okay? So just be very careful with that. Yes, I can go back to the other slide. Yes. I think about this one, my scholar. Awesome. Sweet. So I'll leave this right here for you guys to look at. It looks a little bit janky, but if you follow along with the video, it should make sense. Okay. For the rest of my scholars who are on the Zoom right now, actually, I'm going to stop this right here. I'm going to stop it right here.